This video is looking at using moments to solve problems with sort of structures, a bit more complex. These could easily come up in A-level paper, and these examples, a ladder and a sine, do come up. So first thing we've got to do, and the key skill here, is choosing what point to take moments about to make finding the forces easy. So let's start off with the ladder case. So we've got a ladder here, and the first thing we want to do is start thinking about what forces are operating on the ladder. Well, we're going to have a normal reaction force at the base, and we're also going to need some friction here to hold it, otherwise it's just going to slip over. And at the top we're going to have a reaction force from the wall, and I'm going to assume there's no friction at the top. Sometimes you would get friction, but I'm going to start with this basic model here. Now I've got a choice. If I want to find these forces, I've got three unknown forces. If I want to find them, the best thing to do is to create an equation with only one unknown in it. I could take moments about the centre of this, and I'd have three unknowns in it. I could take moments about the T point, and I have two unknowns in it. If I take moments about this ground point here, this point B, I'm only going to end up with one unknown force in it. So if I take moments about B, what moments am I going to have? Well, the first one I'm going to have is a moment from the reaction force, yeah? So I've got my RT, and I need to know the lever arm for that. Well, if I just completed this rectangle here, the triangle, rectangle, yeah, I can see that in effect my moment arm is the height of the ladder, the wall height of the ladder. Well, let's assume the length of the ladder is L and that the angle that it's leaning at is theta. So that length is going to be L sine theta, yeah? So that's the reaction force moment, and that's clockwise. Well, I've got an anti-clockwise moment to push it against that, and that's the force one here, isn't it, the weight. So I've got the force downwards, and I need a moment arm for that. Well, that's going to be this distance here. Let's assume that the weight is in the middle of the ladder, the weight of the person on it as well, fitting with that. That moment arm is going to be half the length, and then it's going to be the cosine element, isn't it, that distance trig. So I now know what RT is, because RT is going to be F over 2 times cos theta over sine theta, isn't it? So I've now found out what RT is. So not taking moments about T made my life easy. Next thing I'm going to do is I'm going to stick to simple things to do, and I'm just going to resolve forces. So if I resolve forces vertically, then I know that my reaction force off the ground must equal the weight force of the ladder. So that's easy because that's all in equilibrium. And if I now want to look at the ladder horizontally, resolving forces horizontally, well, the reaction force from the wall must be balancing the friction force at the base. Otherwise the thing would be moving, wouldn't it? We might want to check out that we haven't exceeded the critical friction, but in principle we've now worked out all the values for all the forces there. Let's have a look at the sine problem. So this is a old style sign, so we'd be hanging a sign outside our shop, and we want to hang it out into the street. So what we do is we have a little piece of metal sticking out here, which is fitted on a hinge to the wall, bolted onto the wall. So that effectively holds this out into the street, and then we need to hold it up. So we need a wire up here, and it's the tension in the wire that's going to hold this beam up and this sign below it, yeah? So I'm going to create all my forces. The first force we just looked at there is the tension in the wire that's holding it up. Now here's my beam. What's happening at the wall? Well, I'm going to get a reaction force, normal reaction force at the hinge, which is pushing this beam out. There's my beam, it's pushing it out. There may also be a vertical force here because it's bolted onto the wall. I'm going to call it VH for now, because that's probably going to be holding it up at that end. So I've got all my forces sorted out that I'm interested in, I think. The only other thing I need to think about is a bit of geometry. I'm going to have theta as the angle here. Okay, so what do I want to do? I want to find the forces. I've got 3 unknown forces. I want to get one force on its own so that I can find it. So the best way to do that is take moments around H, the hinge point, yeah? If I do that, I've got the tension in the wire holding up the weight of the sine. So let's take moments, taking them clockwise here. So what's my clockwise moment? Well, it's the force of which is the weight force of the sine, and I need a distance, don't I, for lever arm. So I'm going to call that distance W. So that's my clockwise moment. That's being held in place by the tension in the wire. And what I need is the component, the perpendicular component of the tension. So I could break this tension up into its vertical and horizontal components now, can't I? So what's the vertical component? Well, that's going to be V sine theta, isn't it? And then I've got to have a moment. Well, it's got the same moment arm W. Therefore, I can now find out what T is, because T is just going to be the weight force over sine theta, isn't it? There we go. So I did that very quickly because I have one unknown. If I tried to do it with T, the top point would be taking moments about T, it would have been a nightmare. The next thing I can do is I can think about the other forces operating on my beam. The best way to do that is by resolving forces. So if I'm thinking about my beam and I'm resolving left to right, then I know that my horizontal force onto the beam, the normal reaction from the wall, it's got to be equal to the force from my wire, which is going to be T cos theta, because I'm looking at my horizontal component of the tension. So I've now found out what the reaction force is: horizontal reaction, normal reaction. But the other thing I might be interested in is what this vertical force is. So if I took resolved forces on the beam vertically, then my vertical force at the hinge plus the vertical component of the tension force is going to have to be equal to the weight force from hanging off the beam, isn't it? So VH is going to be therefore F minus T sine theta. So there we go. That was a fairly quick way of finding the all the forces. So the key bit in all these cases is choosing the point to take moments about. And you want to take moments such that you've only got one unknown force. And once you've found one of the forces, you usually find it's possible to resolve horizontally and vertically to find all the other forces. So there you go. Hope that's of use.